my lecture today. Of course, today we actually going to be focusing on probability generating function. But this is what I'm going to do. I'm actually going to have a review of what we did before, okay? Because when you talk about generating functions, of course, we actually have a good number of them. So because of that, actually um, going to start my review from uh, number one, arrow to raw moment. Okay, so I told you in the how raw moment is actually uh, written as days, and of course, uh, I show you that we are interested in generating the first to fourth raw movement, and these are very essential when it comes to statistical analysis. And number two, I remember I also walk you through our central movement. Okay, the R central movement, we actually gonna have this equal expected value of x minus mu raised to power that. And we're also interested in the first four central movement. Okay, and I also remember I also talk about R standardized. Okay, R standardized movement. Okay, in the R standardized movement, uh, we know we in our standardized movement we know that z is x minus mu over sigma. Okay, and of course if I want to find the expected value of that, so which indicates this is what I want to do. Okay, and we're also interested in 1, 2, 3, 4. Okay, so in the R standardized movement, if R equal to 1, of course, that is going to give us 0. And of course, we all, by the time we start saying continuous probability distribution next week, we're gonna talk about standard normal distribution. That is going to indicate when R equal to 1 here, okay, that will indicate the expected value of a standardized normal random variable is going to be 0. And of course, when R equal to 2, okay, you're actually going to get 1. So which also telling us expected value of z squared is going to be equal to 1. And when R equal to 3, okay, that will give you skewness. I told you the significance of skewness in statistical analysis. Okay, so then when R equal to 4, then we talk about kurtosis. I remember yesterday, I told you the application of that in finance, in quality control, and so on like that. Okay, so this, if you take a look at all of these, they all center on movement. Okay, and when we talk about movement, if you take a look at all of these, there are some basic, statistics. Okay, basic statistics that we need in understanding our data set can be derived, from this. What are the basic statistics that I'm talking about? I'm talking about mean. I'm talking about variance. Okay, I'm talking about standard deviation. I'm talking about standard deviation. Okay, I'm talking about skewness. Okay, I'm talking about kurtosis. Okay, so all of these are basic or descriptive statistics. They can actually be derived from all of that. Okay, now I'm actually going to, go to. So, apart from this, we also have alternative way that I introduced it to yesterday, that I call generating, movement generating function. Okay, and I remember I told you that also have to do with the expectation. Okay, so mathematically speaking, okay, mx of t, okay, where t, I think where t lie between negative h and h, okay, it's actually expected value, okay, of that. And of course, I actually, the moment you derive moment generating function of a particular distribution, because a moment generating function is unique, okay, it actually, you know, uniquely can be determined. You can actually it specify that probability distribution, and you can determine a probability from that. So now, if I make a first derivative, okay, just like what I demonstrated yesterday, okay, which is having this, okay, if I make a first derivative, okay, and I decided to, maybe I set t to 0, okay, I decided to set t to 0, so which means setting t to 0, okay, it must give you 1. Okay, now before you go ahead to use it to derive maybe the mean, the variance, or the first moment, the second moment, and so on like that, you first need to verify, okay, the moment generating function. When you plug in 0, okay, you should have, when you plug in, sorry, not yet, when you have not differentiated. That's what I wanted to say. When I plug in 0 here, okay, of course, if you take a look at this, if I plug in 0, of course, that's going to be 1. So this is how to prove, okay? So when you derive your moment generating function, if you plug in 0, then if you want to know whether you are right, it should be 1. But when you have the first derivative and you plug in 0, that is going to give you the first moment. That is going to give you the first moment. When I recall to 1 here, it's going to give you the first moment about the origin, okay? Now, when you continue, okay, when you do the second derivative, and set t to 0, okay, setting t to 0 means you got m prime prime s of 0. That is actually going to give you the second moment about the origin, okay? Please look at the connection. And when I do the third one, okay, and set it to 0, okay, which I actually mean this, okay, is the expected value of s raised to power 3. Now, if I want to generalize right now, okay, if I want to generalize, okay, okay, if I want to generalize to k, so maybe I'm actually going to say decay mx of t, okay, the t k, where t equal to 0, okay, where I'm actually going to have ms of this is k, this is k 0. Okay, now when you take a look at this, or let me just say, or let me be using R so that you're going to see the connection, okay, raised to power R, okay, R derivative, then that is going to give you this. Take a look at that, which is going to give you this, okay? There's a connection between a moment generating function and the heart movement. Is an alternative, okay, way. Okay, it's an alternative way. So I need you to pay attention now. Okay, when I'm here, I'm doing the R root derivative and I set it to 0, and that is what I will automatically translate into what I call the heart raw movement. Okay, is there any question at this time? Any question? Okay, now before moving to probability generating function.